In this session, I'm going to show you a tool developed by a researcher as part of his thesis. Carlos at MIT developed an approach, actually directed random testing, and he implemented a tool called RANDOOP, a random object-oriented program testing tool. It takes Java or .NET classes input and generates unit level test cases. They are usually helpful for regression testing in particular, as you will see shortly. So I'll directly start with it and come back to this little theory details. Okay. So my plan is to take an example. So I decided to pick a Java example. So I took an online example so everybody can replicate if they want. A simple vending machine in Java, online available from this particular URL. The goal is to be able to test the classes that they're talking about. Okay, so the vending machine itself is fairly straightforward, right? You insert coins, and you select the product, you get back the product, the correct money, and it will give you back the balance, and then you can reset, cancel, and all typical things that typical vending machine would do. This is programmed in Java, so this particular article has about how many classes? Has about 12 classes. As you can see, vending machine, API, and implementation, factory, item, inventory, coin, bucket, whatnot. So you have all these interesting classes and then some exception classes. So my goal is to be able to test this vending machine mechanically. I want these classes as input and generate a bunch of JUnit test cases that I can use it for my regression testing. Okay, the tool may not know exactly whether the program is doing what it's supposed to do because there is no logic built inside the tool for that. However, the tool will tell me that, okay, if I send in a coin as an input to this particular method, I get back this as an output, and it records that as part of the JUnit assertions. Okay, that we can use during code evolution, which is a problem when source code is changed and there is no unit test. We are not confident whether the product is working in a correct way. All right, so with that little background, let's get directly into the tool and start executing the test cases and show to you how we successfully execute the vending machine example using RANDOOP as a case study, right? Okay. So I'm also now going to show you some more details, right? Before we run RANDOOP, we need to tell RANDOOP what are the classes we need to run. Here, you're seeing the list of 12 classes that I have shown on the web browser. So these 12 classes are stored in a file called classes.txt, which I'm going to send it to RANDOOP. RANDOOP will apply its magic on these classes and come up with a bunch of unit test cases for me, okay? Which it's actually executing it, and then based on the observed output, it creates the assertions. Okay, let's get started now. What you're going to see is my command line interface where I will be running this command. Give me a minute. Command prompt is now shown to you. What you're going to see is basically RANDOOP being called from my command line. This is the RANDOOP jar file, which is available online for free. And then you have to set the class path of your libraries that you're trying to test, right? This is the class path. And this is the RANDOOP main class. You ask him to generate test cases based on the list of classes you mentioned. And there's some extra parameters that I will avoid for now, and I will show to you what it means later. Okay, so let's run this. It may take 1 or 2 minutes, but you will see soon it's going to generate a bunch of classes for me, test classes. Okay, JUnit classes will be generated for me. While it is running, I will show to you the folder setup so you can see for yourself that RANDOOP is actually generating those test cases. Okay, so this is what you'll see when you unzip your RANDOOP zip folder. Except the classes.txt, everything else is part of the distribution that you can download from the internet. Now it's the command line is basically running our test cases on all the classes that we put inside the classes.txt file. As soon as the output is shown, I will share that with you. So the program is actually executed now. There are some printout statements coming from the vending machine class, so we don't have to pay attention to that. These are all actual runs. So RANDOOP is not static analysis tool. It's dynamically running your unit test case, running your classes to produce unit test cases. Okay, and also one more detail that is important to note is that your class is actually viewed as a black box, more or less. It doesn't go inside the details of the methods. I know if your if statement, else statement, it doesn't go into the logic. It is basically testing through the interface. So let's assume this is your class C. It only invokes the methods that are visible. Okay, it doesn't really know what's going on internally. Okay, that's important to know. This is the reason why it can scale for large systems. As soon as you give a bunch of classes, it's exploring it automatically. And it does something more fancy as well. It is automatically picking the classes. It automatically finds out in order to call a certain method, it needs to instantiate other classes. It will instantiate that for you. It will automatically populate values for the fields of the classes so that it can successfully call those methods. Okay, so now a bunch of test cases are created. I'm going to show these test cases and look at the test cases. Okay, so as you can see, it was generated right now, a couple of minutes ago. So here is the JUnit test suite, has only one test class, and let's look into the test class now. Okay, so what you're now going to see is basically the output from RanTube. The RanTube tool generated regression tests test suite, which is pointing to regression test 0.class, which is this class. Okay, this is basically it. And now in this file, whatever you're seeing is basically auto-generated for you. Okay, RanTube generated an instance of, for example, it created an instance of a vending machine class. It created an item which is null, and then it was trying to get item and get price for a null item, which may or may not make sense. But as you can see, when it was running, it got an exception. So it recorded the behavior. So next time when you run it, and suppose, say, let's assume something you fixed in the code, now the assertion will break. So you can rework the assertion if you want, or you can just copy and paste all of these test cases into your nightly builds and just make sure that no new assertions are failing, right? Let's assume when I scroll down further, I will show you some more examples, then it will be clearer. Say for example here, it is doing a simple call to the item class, right? In fact, there's no call, it's just instantiating the item class and assigning to the value Pepsi to the item object. It is now asking get name, right? And it was able to, based on the actual execution, it found out the values are Pepsi in both cases. Say somebody modified the item class for whatever reason, and now no longer this is the case, then these assertions will fail. Line number 40 through 42 may fail. Thereby you find out some problems, okay, in the code during the regression. So my personal opinion is it's mostly valuable for regression testing. If you take time to review these test cases, you may polish it and make it better and integrate it as part of your regular unit testing as well. Some of the test cases make a lot of sense and they look like a human generated one. Okay, for example, here you create an inventory, instantiate your vending machine, asking the refund right away, and then inserting some things into your vending into your inventory, getting the price. It may not be super close to what a human would do in each and every case, but it's free. As you see, in 1 minute, I got all the test cases. Okay, and all of these test cases are automatically generated. That's the most important point. There are many options inside RanTube that I will quickly go over a little bit. You can make use to polish your test cases. Of course, if your test cases are more dynamic, meaning let's say the output is a time or a date, and if you assert, if RanTube asserts based on dynamic data or random number, things like that, then those test cases may fail. So you need to be able to mark certain methods are not good methods, so you can explicitly exclude some methods and some classes to make this more usable. Okay, so essentially that's the core of my presentation. What I wanted to show to you is how you can mechanically generate these kinds of test cases. As soon as you know the list of classes you wanted to test, all you are doing is basically call RanTube that explores this space of all possible objects that are reachable from outside. It doesn't go inside the method, right? If there's if then else class, it doesn't know that it has to hit those systematically doesn't go inside and do a symbolic execution kind of technology, but it's doing it from outside. Okay, that's why I said interface-based testing. All right, so basically it, and very quickly show you the important configuration features inside RANTube. So let me show you that. Okay, so the RANTube manual has lots of features, right? For example, you could specify what class to test, what method to exclude. Let me show you some, right? Method list and things like that. You see here, there's a method list, class list, and which class to omit, which methods to omit. All these things you could specify. It also has options to run out of memory error and things like that. So that's good, especially if you have memory leaks. For example, in my output, there was a file called error.java where it listed some scenarios, and then you may look at it later for null pointer exception and things like that. That's one good part. The other part is, as you saw, real test case, JUnit test case coming out for free, and it also has some basic contract checking. It checks whether the equals method is reflexive, symmetric, transitive, and so on. Some very basic contracts over objects are also mechanically checked for you based on the generated test cases. And there are many more options. Let me show you the constants that are used. For example, if your method takes an integer, it will automatically put values 1, 2, 3, but it will also for example, 1, 2, or so on, 3, and so on. It also will use the output coming from the previous run as an input to the next call. That's really nice. That's how it is able to generate somewhat meaningful test cases. Okay, so this manual has all of the other options, like how much time it should run, how many test cases, and so on. You can control some of those behaviors using this technique. And that's basically what I wanted to show to you. Thank you.